In Lesson 1-6, we're dealing with inequalities. Remember, those are like the symbols less than, greater than, or less than and equal to, greater than and equal to. But we're also going to talk about compound inequalities. That is, multiple ones at the same time. So when it comes to creating them, we have Sarah who wants to invite at least 10 friends to her party, but she only has the budget for 30. We would create one. Might that say X is her number of friends, and she wants to invite at least. So she wants to invite more than 10 friends or equal to 10 friends. But she also has a budget, so she needs to keep her number of friends less than or equal to 30. Both of those alone would make up her correct number of friends, and if we put them on a number line, it'd be 10 or more, but 30 or less. One way we also will start to think of this is an and compound inequality. That means she wants to invite 10 or more people and less than or equal to 30 people. She has to fit both of those inequalities. So sometimes you'll have to think of how you might create them. We also want to be able to represent them on number lines. So for this first example, we would note that -2 has a closed circle and 3 has an open circle. 3, we want our x to be greater than 3, so that takes out b and d, and we also want x to be less than or equal to -2. Our key word here is the or the and. When you go two opposite directions, you could either go, say in person, one way or the other way. That's why A is going to be our best choice. Remember, generally when we're dealing with the word and on a compound inequality, the shading is overlapping. Both of the inequalities are satisfied at the same time. There's no way that one could have a higher number than 3 and a number lower than -2. No number fits those criteria. So, for example, on the bottom here, we have a compound inequality that's graphed for us. We could say we want a number that's greater than -4, but we also want a number that's from 0 or below. This is going to be another and compound inequality. It's going to be x is greater than -4. Note that I won't use the underlining because it's not equal to, but x is less than or equal to 0. Now you'd want to use the word and. X is greater than -4 and less than or equal to 0. Another way you could write that, though, is like this, as a double inequality here. So we would put our 0. Both of these say the same thing, but this says the x value must be between -4 and 0. Sometimes you're going to have to solve the equations, or inequalities, that is, before you know which way it's supposed to be shading. And you've done that in the previous section. So here we'd have x is less than 5. We know these ones are not an option. And if I subtract 5, I have -x is less than or equal to 3. Dividing by a -1 will change my x to positive, but it also flips the inequality. And I have x is greater than or equal to -3. So D would be my correct answer. Again, your biggest thing is to remember that and will generally involve an overlapping of shading, or will generally go the opposite direction. In one last tricky example up here, a special example might be when you have x is greater than or equal to 3 or x is greater than or equal to 7. It's really important that you pay attention to this compound word. If someone told you you had to be greater than or equal to 3 or greater than or equal to 7, say 3 and older to ride the ride or 7 and older to ride the ride. If you were given the choice and say you were 4 years old, you would definitely pick the x is greater than or equal to 3. So because you can be any of these numbers or any of those numbers where they're double shaded, we actually just use this first inequality because that will fit both of those situations. Being greater than or equal to 3 would also include all those numbers greater than or equal to 7. So when given the choice of being able to do something at 3 or 7, you'd likely pick 3. Whereas if someone said x is greater than or equal to 3 and x is greater than or equal to 7, that would mean someone would say, you must be older than 3 for their rule, but then they say you must also be older than 7. You can't be 4 and fit both of those. So in this case, we would focus on just those being greater than or equal to 7, because these numbers out here are all fitting the x is greater than or equal to 7 inequality.